We are based in London, and I'm here to talk about memory dumps, and specifically how we can use memory dumps as quite a general tool for debugging and finding issues in Android. First, before I get started, I need to say a few things about my company, which gracefully sent me here and paid for everything. So, what is Badoo? Well, Badoo is a social networking platform where you can meet new and exciting people. We have more than 260 million users worldwide. On Android, we're big as well. We got around 50 million downloads on Google Play. And we're hiring, so if anyone looking for a job, really well paid in London, which is an awesome place, we're hiring. Right, with that said, let me get to the actual presentation. So, memory dumps. I'm sure probably, maybe all of you in the audience, at some point you have used memory dumps. So I'm not going to bore you with all details, but I want to see a few things about what a memory dump is first of all. So memory dumps, basically is a big file containing a complete image, almost, of your application at a certain point in time. What is in a memory dump then? Well, there are some obvious things. For example, memory dumps, you have a complete set of all the allocated objects at a certain point. However, there's a bunch of other things that you actually need to be able to make sense of a memory dump. So first of all, you need to know what those objects are. So you have something called class definitions. These are quite similar to how your class definitions are in your source code with some limitations. The class definitions here, they tell you what is in each instance. It tells you all about the fields, the public, private fields, and so on, and constants as well. However, just having those two things isn't enough to make sense of a memory dump. We also need a third thing that's very important. Strings. Strings tells us a couple of different things. First of all, it will tell you what the names are of the classes you have. And it also tells you about what the fields are named and so on. So without this information, a memory dump isn't very useful. There are other strings though as well, as you can imagine. In your application, maybe you're getting some JSON data from your backend, or there might be strings that the users entered in the edit text. So there are quite a lot of different strings there as well. So that is basically a memory dump. So what are we using memory dumps for? Currently on Android, we use memory dumps mostly for one or two use cases. And usually it all revolves around finding or fixing memory-related issues. Usually it has to do with our memory errors. Probably all of you have at some point encountered one, and it's usually not the most fun thing to deal with, because usually you're a pain in the ass. And also finding memory leaks. So these are two use cases, although in reality it's basically one use case. So usually when you have a memory leak, sooner or later you can run the memory, get an out-of-memory error. And this is also what I've been using memory dumps for the last 5 years or so. And when I've been doing this, I've been digging around a little bit more to see what's actually in a memory dump that I could make use of. And I got this idea that it would kind of be cool to do some more stuff with memory dumps. And the main idea I had was that I would like to use memory dumps to analyze some other issues which aren't strictly memory related. So like I said, there's a ton of data in memory dump, and it seems like a waste just using this to find out-of-memory errors. So when we're doing this, there's a bunch of very useful data in a memory dump that might help us in several ways. So first of all, you have some very Android-specific data related to the state of your application. For example, in the memory dump, we have such things as the whole activity backstack, for example, which can tell us where the user is right now, as well as where he was previously. And about where he's doing right now, we also have things like the view hierarchies. So basically, in there in the memory dump, if you pull the data out, you can actually see exactly what was on the screen at the time when the memory dump was captured. Well, at least if you like to parse view hierarchies by yourself. And besides all the stuff going on the screen that the user is seeing, there's a lot of stuff going on in the background as well. So we have things like the states of your handlers, your threads, services, loopers, and so on. All this is in there in memory dump. And if you know what to look for and how to actually read the data, this could be a pretty powerful tool. So my idea was that I want to take these memory dumps from the user's devices and bring them home to me, analyze them. Though the problem was I quickly ran into some basic problems with the way memory dumps currently work on Android and Java. And it all has to do with the format that is used for memory dumps on Android. So we have something called hprof. And hprof is a lot of fun. So to give a little bit of background first, hprof is not something invented for Android. hprof is the standard Java memory dump format. And it has been around for at least 20 years. So probably longer than some in the audience. So it's not really up to date, so to say. And the major issue with it, which was the thing I first encountered, was that these files are usually pretty damn big. For example, on Android, on a high-end device, you might be able to allocate several hundred megabytes of memory on the Java heap. Of course, on older devices, it will be much less, but still, you will at least have a file that is up to 50 megabytes, up to several hundred megabytes. That is, if you actually allocate all the available memory, which might be the case. And, well, you might think, well, that's not really a big problem, right? Because I just plug in the phone and pull those files off it. But if you want to do more than that, if you want to analyze issues that are coming from your users in the field, 200 megabytes start to look very, very big. Imagine asking your user, can I please transfer this 200 megabyte file to our servers? I think most users are not going to be very happy about it. Even if they're on a really fast Wi-Fi connection, it will take some time for it to transfer the file, and you'll probably drain your entire battery. So that's not very much fun. There are other issues too that are not purely technical nature with hprof files. And it's something that should be on all our minds as Android developers, and that is privacy, and also security. So what's the problem here? Well, there are two main privacy and security issues with memory dumps, and they're both related to that data that's in them. So first of all, let's talk about bitmaps. Usually in a memory dump, bitmaps make up quite a big portion of the memory dump. Since, I'm not sure which Android version, but these days, bitmaps are stored on the Java heap as byte arrays. And this takes up a lot of space. Okay, so what is the privacy issue about bitmaps? This kind of depends on what your application does though, but to give a real-world example, in Badoo, we allow our users to send private photos from one user to the other. Usually, there might be a picture of a cat, I don't know, it could be something a little bit more, well, not something that your users would like to have leaked or anyone else have access to. So it's quite important to protect that data. Besides this, we also have strings, and strings can actually be an even bigger problem. Some strings are completely harmless, like the class names. No one is going to be mad if you leak the class names. But it could be other things as well. For example, if any of you are using any kind of third-party library, for example, Facebook or Twitter or Instagram, to access users' data, what you usually have to access that data is an auth token or a session key or something similar. And if you are using this, it's probably going to be in memory as well. And if it is in memory, it might end up in memory dump. And if someone gets their hands on this key, they might be able to, for example, access a user's private photos on Facebook, post something to their wall or something similar. So these keys are also very, very sensitive. So here we have a pretty big problem. We have all this sensitive data, and for example, when we are dealing with sending this to the server or getting it from the server, we are very careful to always encrypt it, and the same goes when you store it in the disk. So this means that if you want to deal with memory dumps, you need to be at least as careful with the memory dumps as you are with the user's data when it's in transit or on the server. Right. So At this point, I was feeling a bit down because this meant that there was no way for me to actually do any cool stuff with memory dumps. But I'm an engineer, and when I see some limitations, I either try to improve things or reinvent things from scratch. And in this case, I sat down to try to figure out what would be a better memory dump compared to the existing formats. And I came up with a short list. At the top is the first thing I mentioned before, file size. So I want to have a memory dump format which is actually small. This might seem a bit counterintuitive because the reason why I wanted memory dumps in the first place was that they contain all this useful data. So how can you make a small memory dump? Well, turns out it's not really that hard because if you focus on only including data that is relevant, you can actually get a pretty small file. So what is relevant? Well, that kind of depends on what you want to use them for. So in this case, we need to be quite flexible. If I want to use this to maybe find some problem with my event bus, maybe then I only want to have data about my event bus. So you've got to be selective. And another small thing is that I also want to have a file format that's easy to read and write. This might seem not very important, but like I mentioned, on Android we are stuck with H profiles. And this means that if we want to use any other kind of file format, we need to be able to do a conversion on the user's device from HProf to your new file format. The thing is that if you're dealing with several hundred megabytes big data files on a mobile device, you're going to run into performance bottlenecks. Because there are a lot of limits working in a mobile environment, and a big one is I/O bandwidth. We have pretty fast CPUs these days in the phones, but they still work with flash storage, which in some cases, at least in some devices, can be quite slow. So you've got to be careful when you read and write data. And ideally, I would like to do this in the background in a way that doesn't interfere with the user's experience of my application, as well as not draining their entire battery. So it's actually quite important to have a good file format. Right, so at this point, when I had this list, I started hacking away at this. And I came up with something that I very immediately named BMD, short for Badoo Memory Dumps. They say that naming is one of the hardest things when developing new things, and in this case I was kind of lazy because I mostly cared about the technical stuff, so that's why it has this lovely name. Okay, cool. So what is BMD? Well, BMD is a file format which checks all the boxes from a previous slide. So it's a memory dump format which is small enough to be portable. And it does this in two ways. So first, like I mentioned, we only include the data we only need. But it turns out that this isn't enough. Even if you only include some very useful data, you might go from a 200 megabyte file down to 50 megabytes. And 50 megabytes is still too big. So what I had to do at this point was look at how we can better encode data. And instead of reinventing the wheel, I borrowed some stuff from some really smart guys working at Google, because they usually do a lot of cool stuff. And in this case, I borrowed something called protocol buffers, which is something we're also using at Badoo. And it's a very efficient way of encoding data to be transmitted, usually over the network. And in this case, I borrowed a really nifty thing called variable length integers. In HProf, if you want to store an integer, it will always use 4 bytes, which is how it is in memory as well. But if you want to store an integer on disk, you can actually use much less space than those 4 bytes. For example, if you have the number 1, well, that can be easily represented by a byte instead of an integer. So why use more bytes to store the numbers that you really need? It also turns out that in a normal memory dump, quite a big portion of the data is actually integers, or short or longs, or even floating point numbers. This technique can be used to encode these all quite efficiently. Also, the second part was dealing with strings. And here I wanted to be sure that I didn't leak any of those access notes I mentioned before, or any text that the user had written. So what I did here was that I wanted to give, well, Preferably, I would like to have no strings at all. But like I mentioned before, you need strings to be able to make sense of memory lines. Because if you don't have strings, you don't have class names or field names. So what I did at this point was that instead of storing strings themselves, I'm using hashes. The beautiful thing about hashing strings is that, first of all, you turn a long string into a very short number. The second nice part about hashes is that you can actually take that number and get the string back. Well, not quite so easily, but if you already know the string, you can actually get it back. This is how usually passwords are stored on your computer. So when you're signing in, we are not matching what you entered with some stored clear text password, or at least it shouldn't be. Instead, you're comparing two hash values. I'll get back to this later when I talk about how we can take this file format and get an HProf back again. Right. So like I said, we only include the data that we really need, which is quite depending on your use case. The nice thing about this file format is that it's all open source. It's on our GitHub page, and you can easily customize exactly which data you want to include in the memory dumps. And about the efficiency, it's also very easy to read and write. If you work with HProf files, there are some issues with it, because, for example, you cannot just read an HProf file in one go and be done with it. You need to back up and read it several times, and resolve dependencies, and so on. With BMD, the whole file can be read from start to finish without dealing with stuff like record headers containing sizes and so on. You can just read it in one go, decode it, and have an image of what's going on. Okay, enough with that stuff. So what does this mean? What can we actually do at this point? Well, this means that, okay, actually before I get to that, I'm just going to show you some numbers because I like to show off. So this kind of shows how well BMD compares to HProf. And there's only one number that you really need to care about here, and it's the one encircled in red, 1.8%. So this is the size that's left over after you convert from HProf to BMD. In this particular case, you had a 210 megabyte file, and the output is a 3.8 megabyte BMD file. That's pretty good, but that's not it. If you then take this file and run it through a gzip output stream, for example, you'll end up with a file that's maybe 2 megabytes. And what does this mean? Well, this means that we have a file size, well, we have a file that's actually small enough to be portable. It might take a while to upload over a 3G connection, but most of your users will actually be okay with uploading this kind of file over Wi-Fi, for example. We know this at Badoo because we already allow our users to upload their photos, and photos can easily be several megabytes big. Alright, so what does this allow us to do? So at this point, we now have a file format which we can convert on the device from HProf to BMD. And after we've done that, we can take this file, upload it to our servers, and from there you can just pull it and use it to analyze some issue. So once you have the file though, you still need to convert it back to HProf, because the thing about this new file format is that there's no support for it, there are no tools. So you still need to go get back to your HProf file. Right, okay. And at this point, you could theoretically at least use this to analyze any kind of crash we're having. But since dealing with these files is a little bit of a pain, you kind of want to use this for those crashes where it isn't enough to just have your regular stack trace or maybe your little log snippet. So you could save this for analyzing crashes that are really, really tricky, where you need to know everything going on in your application at the time of the crash. Because the thing here is that you are moving from having a problem where you cannot figure it out to a problem where you might just have too much data. So here the idea would be that you really want to select very carefully what data to collect. Right. So with that, I would like to show a really quick demo. I hope it works. Actually, I already pre-recorded it, so I think it should be fine. And what I'm going to show, first of all, is how you can integrate this library in your application. It's super easy. and as well as what it looks like when you have those files, when you convert them, and what they will look like in some memory analyzing tool. Okay, let me see if this right. It might be that the resolution is really, really bad, so probably you might not actually be able to read it. Okay, cool. So first of all, here we have our main activity in onCreate. We have a call to HProf catcher init, and this works similar to how you use, for example, criticism or HugApp. So we make this call and we register an uncaught exception handler. And this uncaught exception handler, what it would do is that on a certain exception that we're interested in, we then collect a memory dump. After this is done, your application will crash like it usually would, with a little short delay for writing the file. However, the interesting part comes when the user starts the application the next time. So at this point, we have a service which checks the file system to see, are there any HProf files here? And this we'll see here. So we have having two actions, one for crunching the string in the files and converting them, and another one for just checking the file system. And this goes on in the background, and you can even customize how much CPU time you would like to use for this process. For example, if you want to do it very slowly in the background, you can specify a longer delay so that we do this very slowly. And once it's done, you simply get a callback. In this case, it's in the form of, okay, I'm going to stop this. I thought it would be nice with a video. Turns out it's pretty tricky. Okay, so, right. So you get a callback in the form of a local broadcast. And at that point, this is where you take over. You now have your BMD file. And probably what you want to do at that point is either upload it maybe, or if you want to make it really, really simple, you can simply start with intent and launch the user's email client with your file as an attachment and ask them, can you please mail this to our support if you want some help, blah, 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 and off it goes. Okay, let me see if I can restart it at a certain point and we can see what it actually looks like in action. Okay, here we go. So this is showing a very simple demo. Got a button here for causing a null pointer exception, very useful button. I think you should all have one in your apps, and it crashes. There we go. So let's restart it. And if you can see it, we are now crunching in the background. And this may take some time. This is in motion though, so this is actually pretty fast. Let's see, this thing is going to change in a second. There we go. At this point, you have your memory dump. All done. And the next step now, I'm uncheating here a bit because I'm pulling the files off the device, is to convert it. So how do we do? Well, we have this decruncher application which takes the BMD file as well as an additional input. And in this case, we're giving it Android.jar as well as your APK. And the reason why we're using these extra files as input is that we need to get those strings back. And the way I do it is that I parse through the jar file and the APK file, pull out all the strings in there for class names, field names, and so on, hash them so I can compare it with all the hash strings from the memory dump. Okay, so let me show you how this looks like when we open it in, we have one more thing. This is to convert it to regular Java HProf from Android HProf. Manual lines. I never figured out why Google didn't use just standard HProf, because they don't really add anything useful to it. Okay. Okay, you can see the file size. So the HProf file you end up with is approximately the same size as the one you started with, because I tried to fill in all the blanks so that you can still compare, for example, the size of some arrays and so on. Right, so this is completely unreadable, because Eclipse memory analyzer doesn't allow you to change the font size. What you would be seeing if you could see this is that you see a nice list of classes right here, which actually has readable names because we recovered them. And what you can see here is that, well, let's see, what are we seeing? Oh, it's the same resolution here. Nice, very useful. What you would be seeing is that you can actually, for example, see our main activity right there in the list. And what you see right there is the same file recovered without having access to the APK. in that case, you have no main activity. What you have instead is something called something like hash string and then a big number. So not very useful. So you really need to have the APK as well as at least something similar to the Android jar file that you use to build it, although they're quite similar to the platforms. Right, so that concludes the demo. Let me share this. That is the GitHub page where all this is available. Check it out if you feel like it. You are very welcome to pull requests if anyone wants to change something. Also, maybe there are some questions, if anyone has one. I don't have any gifts. I don't even have any stickers, but they are welcome. Yeah. Yes. You can actually take a memory dump at any point, but there is one problem though. While you are recording your memory dump, the whole VM is stopped. So the user experience is not going to be optimal. You might press something and then it stops for a couple of seconds. So not so much fun. No. Possible though.
So does the capturing of the heat, does that occur for those untainted sensor?
Yes, exactly. That's how it is. So it will still work together with your regular hockey app and so on, because the exception handlers are chained, so it will just call through to the next one. Something that could potentially be useful if you're using hockey app, you have crash keys to identify a certain type of crash. You could probably use the crash key to select that you only want a memory dump from a certain crash you're investigating, for example. Possibly. I haven't tried it.
You can show how to customize what is the content of your
Yeah, sorry. Even if
I mean, if you do something, you have to change the continuity?
no. Well, it already supports some basic customization. Right now, what you can change is that you can select that you want to keep more details for certain classes. For example, by default, I actually discard all primitive fields of all classes, of all instances, because in most cases, you're mostly interested about how objects relate to each other to see the chain of the whole heap. But you can specify, say, you want to keep all information about your activities or of your services, for example. But if you want anything beyond that, then you would actually need to add something, although I am working on it currently. Yeah. Oh, very good. It is because it's just a simple demo and I didn't bother creating an application, but that would be the correct way of doing it. In this case, I just guarded it, making sure that you only do it once, so even if you relaunch it, you will only do it once. Okay, cool. Anyway, thank you all for coming and listening to this. You were an awesome audience.